To summarize what we've seen so far, we can say the following. If we have an equation of the form a y double prime plus by prime plus cy equals 0, and I'm using y here, we can use y or x for our function, and we're going to understand that the derivative is with respect to the variable t. Using y for the function, we could specify that the derivative is with respect to variable x and that y is a function of x. But for now we'll just stick to the idea that derivatives are with respect to t. Okay, so that if we have this equation, in general, our strategy is to assume y of t equals a e to the rt. Substitute, and of course that substitution will involve finding the derivatives y prime and y double prime. So before we substitute, we probably want to find those derivatives. Then divide through by ae to the rt, because every one of these terms will have an ae to the rt as a factor. And then solve the quadratic. I've messed that up, haven't I? So I'll just block that so we aren't distracted by it. So we solve the quadratic equation for r, and then we substitute the r values into a e to the rt to get our y function. One little caveat here is that sometimes if the discriminant of our quadratic equation is 0, if the discriminant is 0, then we're only going to get one solution, and we'll have to deal with that. So if only one solution for r, there's a special technique for obtaining two solutions. And we'll get to that technique a little later. It's a fairly simple technique, and it's really not difficult to apply in this context. If A, B, and C are all constant, this always works. Now, if the equation is of this form, a of t y double prime plus b of t y prime plus c of t y equals 0, then this process won't work. Assuming that a, b, and t are not all constant functions. And we can also say that for most functions a of t, b of t, c of t, we won't be able to find a closed form solution. Now, what do we mean by a closed form solution? A closed form solution is just one where we can actually write out the function in terms of sines, cosines, exponentials, and so forth.